Hello. This video is to give the user some guidelines in using the simulated steam plant control system. What we've done at Knox Automation is create the programming for the Honeywell DCS to run the steam plant as described by the functional description provided by FB&D. We also simulated all of the IOs, or the inputs and outputs. So with the simulated I/O, if someone goes to start a motor, that start signal will then turn on a simulated running signal. It acts like real life if everything was perfect. So if the program turns on an output to open a valve, then we will turn on the open limit switch. When that output goes off, we will turn on the close limit switch. The same goes for simulating analog I/O. Analog inputs being levels, temperatures, and pressures. Analog outputs are things like valve position, pump speed, etc. We're using the actual logic that will be put in place at the mill. We also have it communicating with the BMS, which stands for Burner Management System. This is a separate control system running on an Allen Bradley platform that controls the purging of the burner system, the igniting of the burners, and the master fuel to the burners. We have a special way of putting together the level simulation for our tanks. They're very realistic and based on the size of the tank, how much is going in, and how much is going out. So it gives us a good idea as to how quickly the system will react to level changes. The simulation works well, but the other thing we wanted to do is to be able to cause upsets or failures and change input signals for various analog devices. Down here at the bottom of the screen, you'll see the Sim Global Reset. If you've been working with the system and you've been bypassing the simulation and causing failures, maybe you got a little lost, can't remember everything you bypassed, this will reset everything back to normal simulation. If you click it, it will pulse for a second, and that would reset all of our simulation objects. This object below it allows us to hide our simulation objects. Not these objects, but these will be little play buttons that are on our screen. I will demonstrate that now. These little play buttons are our simulation icons. We can make these disappear to make our screen look more like what it will at the mill. And now our little play buttons are gone. I'm going to make them visible again because we will be using them. So next you'll see we have these 4 switches down here. These are used to fill up these four tanks. Because of the realistic flow rate in and out of our tanks, filling could take quite a bit of time. Use these if you run a tank dry or low and don't want to wait for it to fill in real time. Just click on the fill button and it will set it back to a normal operating range. So now I'm going to go to our raw water and demonstrate how you might utilize one of these simulation objects. These are our raw water pumps. They have an auto swap. First, I need to enable the auto swap. Then I'm going to do a failed run on this pump. You'll see I have 3 options. This manual off on. This is not manual on off. This is a manual control of the feedback. So I'm going to click failed run, and then when I turn this on, this pump will get a bad process value and the other pump will take off. I'm going to turn that off. I'll acknowledge my alarm. The other thing we could do would be a failed start. So this is how it works for motors, and let's take a minute and do a valve. So this valve is open. I'm going to make it lose its open limit switch. And there it went into alarm. So you can see there's lots of things that we can do to cause just about any error that you want with the digital devices. So now I'm going to talk a little bit about how we simulate the analog information. This is for a motor load. When you select manual, it's going to put whatever is in this box into the control module for display and for control. In this case, it's saying the characterization on this is linear. That means the number that you enter here has to be from 0 to 100. This is showing 0 to 100% of full amp load. If you want to simulate a bad process value, just keep NaN in here, which stands for not a number. We'll turn this on, and the pump will get a bad process value. Turn that back off. Now let's head over to our RO filter bank 1. Anytime we have a field device that is operator initiated, such as a control stop push button, we simulate what would happen with that by clicking on it. It's just simulating an operator pressing the button by clicking this box. These will not be on the final graphics. I'm going to give you another analog bypass example and talk some about linear scaling. Here is the outlet conductivity. When the conductivity gets too high, it will cause a permeate divert, which we'll discuss more in our RO skid video. I click on the simulation icon and it says the characterization is linear from 0.01 to 200. So that means if we wanted to have 200 displayed there, we would put a 100 in this box and turn it to manual. You'll see now we'll get 200. If I put 75 in here, we'll get 150. So what you're doing is putting in the percentage of the range between high and low. So let's look at our differential pressure here, which is just a difference between these two sensors. There's two ways you could cause an alarm here. You could override the simulation on the pressure sensors with high or low values, or you could change this value. Let's click on it. Notice under the characterization, it says none. So that means any number you enter in here between 0 and 150 will appear here. So we have 60, we'll turn manual on. We got 60. Let's go 33.5. 33.5. Take that off before it goes into alarm. Now I'm going to head to the manifold page and show you our sheet break. We can simulate a sheet break just by clicking this button here. It's going to cause the flow to follow a ramping down pattern. So this is simulating a sheet break on number 1 and how the system would react to that. You don't have to keep this box checked. You will see as it starts to ramp down, the pressure will start to increase, and then our boilers should back off our load. It's very important that as an operator, as you go through this and you're training and causing errors on different pieces of equipment, if something happens that is unexpected or you feel shouldn't have happened, then we need to know. This is the same logic this logic is very similar to what will be going in at the mill. Hopefully about the same. We know there will be changes, but you need to let us know about anything so we can investigate if it is a simulation problem or a logic problem, and if it's something that we would need to address. So anything that you see that needs attention on this system as you're going through it should be relayed back to Knox Automation so we can investigate what happened and maybe get some clarification on it. Maybe the simulation can be improved. Maybe it's a logic scenario that we didn't anticipate. So your help is very appreciated. Stay tuned next and we will discuss the raw water.